Okay, so can you see that? Pact service.
Yeah.
Yes, and this is now without the little nice.
Right. So first thing I want, so the talk today is about Pact service in Chainweb. So we're not going to, Emily's going to be doing the next meeting, talks more about Pact.
Okay.
This is about all the components that come together to execute Pact and every piece in that flow. And there's a lot of flows.
If you want to go more into depth in the actual execution of the transaction space, like stepping into apply commands, I can do that.
Yeah, I mean, this doesn't do much with transaction exec, so either we'll do that today, or if we run out of time, we'll talk more about transaction exec.
Okay.
Transaction exec, this part here is more, is really Chainweb interacting directly with the Pact interpreter. So,
Yeah.
So we can either describe that today, or my goal today is to give people an understanding when they're looking at Chainweb of where they go to find out what various things do, and at least have these diagrams to kind of document it. And yeah, it's very light on transaction exec, so.
Well, I can focus on that tomorrow because I doubt I'm going to be going completely into Pact and describing the evaluation strategy. So if we could focus on that, that'd be fantastic. There's a lot to talk about.
Okay. Okay, maybe that's a good. So moving to the let's see. Start with, they're kind of in reverse order that I wanted. So, oh, sorry, but what I want to do is kind of describe each one of these components. Okay. So the way I broke up things more or less corresponds to modules somewhere in Chainweb. I didn't name those modules just yet because I didn't have time, but that's something I'd like to do, is just say, but most of these, anytime they have some kind of a label like insert in them, that's the actual name of a function that has the kind of like nitty-gritty logic. So I tried to make this useful where you could grep for these things and be able to see what's happening. The other thing is a kind of rounded thing means an API endpoint, or either, in this case, we have actual Pact API endpoints here, send, listen, pull, and local. And then I blended that with the handler names of the actual handler functions that, again, do the business. Pull calls internal pull, local calls local handler, etc. Same with mempool. Mempool has direct function calls into it and uses, I believe, IOREFs to make that safe, make that multi-thread safe. So anytime you see a box, that implies that there's probably some kind of thread safety thing going on or not. But that's generally, these rounded arrows would imply some kind of, handoff to another service. If it's a square block, I'm talking more about implementation. So that's just that. So when we talk about Pact, Pact, all of its API calls are behind a queue. So that's why these things, so, there's APIs and there's APIs, there's REST APIs, but then anytime you kind of expose a service internally, it has an API too. And in the case of Pact, that's this thing called Web Pact Execution Service, and it's got these functions. And then I put the name with the square block, I put the name of the handler function. In the case of new block, it's exec new block. In the case of validate block, it's exec validate block. I didn't do that here because these are just incredibly simple. Finally, these are kind of, is Lars and Colin on the call?
Yes.
Okay, so
yes, yep.
Okay, so I might have gotten a few things wrong with this, but I tried to find where these things are being called. So One thing for the group to note is that Miner and WebBlock header DB could also just be called consensus in a way as far as Pact is concerned, but we talk about consensus a lot, so I wanted to actually give an idea where these things are in the code, but you can consider these two components, and especially WebBlock header DB, to be part of both sync and consensus.
And they should be read-only for anybody who is not consensus.
Right, well, as you'll see, there's nothing, you'll see,
Yeah.
Notice how there's no rounded blocks for these. That means there's no API calls going to Miner or going to WebBlock header DB. And then as far as databases, and then there's the check pointer. Its main job is to provide a history-aware database that can rewind when a fork shows up. So we'll talk a little more about that. But the main thing, it actually has two kind of main databases in it. It maintains the Chainweb Pact DB, which is what gets used by Pact, and that's a rewindable Pact database. Important to note that this is a linear rewind, which means if you get a fork that goes back 3 blocks, you erase everything after that. You get a fork that comes in later that it forked off a little later, but you played a different fork. You have to sometimes you have to go back. It has to do a whole bunch of complicated things in order to rewind and then essentially replay back to the fork you're on, which creates a little bit of extra work. In practice, it actually isn't that bad. I'm not going to get so much into the check pointer as much as talk about its role, just so that you know when something involves the check pointer, as opposed to this being a deep dive on the check pointer. The other thing that the check pointer does is maintain a similarly history-aware view of transactions that have been seen at all. So this is our global transaction index, which is of interest to all these things are available via APIs. That's why there's no API endpoints here. You'll see where these things come in as we get to the first, how these things are used by a user in the following slides. Pact service is the big kahuna that handles a whole bunch of things behind the queue. And what we mean by behind the queue is that it means that Pact, this entire diagram as far as this talk is concerned, should be considered for a single chain only. There are 10 of these, except for things like WebBlock header DB, Miner, and Payload DB. Everything else is per chain. So when we say we have a Pact queue, we mean that there is a queue that is in a single-threaded fashion, it's in a multi-threaded fashion, it accepts requests, but then it does a FIFO to parcel them out to the Pact service on a single thread.
Is Payload DB not also per chain?
It might be under the hood. That's a question.
No, there's, well, logically, yes, but implementation-wise, it's all just content address. You have a hash, you get it back. It's just a single RocksDB table.
Yeah, and we hash things like it's hashed based off of stuff in the header that has the chain ID in it. So
yeah, then
as Lars says, the content addressing is logically multi-chain, but it's a single service.
But actually, if you try it on the web API, it's below the chain endpoint. But you can put in, let's say, you put chain 0 and you put in a block from chain 1, you get a result actually.
Right. So it's really
okay.
Check that.
Got it.
All right. So that's the kind of component layout. Any questions about that before we dive into the? No. Okay.
Right. Maybe one question. This process TX, is this just an index into the payload DB, or do we store some extra information there that is kind of strictly more than what is in the payload and maybe the output?
You'll see. When I say we hit the payload DB, it's really hitting the payload DB, and it's.
I mean the process TX. it seems like it's a duplication there, kind of the transactions are stored in payload DB, and so what is process TX storing in addition?
Process TX is a, why do we not use, because payload DB can have orphans in it.
Yes, it can, and it doesn't allow you lookup by height, so it might be by TX ID. It might be just an index. I don't know.
No, it actually is. It's just hash. It doesn't have. So it says process TXs, but it's really just process TX hashes.
Okay.
So that's a good question. But the whole point is to make something that is following the kind of linear logic of the checkpoint, so that if a transaction was orphaned and came back and got stuck somewhere else, you'll get that view.
Yeah, and it makes sense because payload DB doesn't give you TX index level granularity. The index is only per block, so you can't look up an individual TX. So process TX would give you this level of granularity, I guess.
Exactly, and that's why it's in the relational check. Okay, any other questions about this before we dive in? All right, let's go. All right, so the first one, that kind of real-world users do is send in our send endpoint actually accepts batches. Most of the time, people are just sending in one, but that's why I got the little human sending in ticks is because this actually sends in a vector of user transactions to the send endpoint. And again, this is per chain, so this is sending to chain 0 or chain 1, but only one chain. So send handler interacts directly with mempool, mempool insert. Hold on 1 second. So send handler directly interacts with mempool, which again, it can do, even though this is a, obviously multi-threaded, any endpoint is going to be being hit on multiple threads. Insert in mem just uses, anytime it's going to hit any of these things, it just uses various IO refs. So the first thing it does the pre-insert check. The pre-insert check is basically running what we call validations on the transaction. So we do everything from, it actually does involve transaction exec because it will run gas purchases. So it does a whole bunch of stuff to try to prevent DOS attacks. But the important thing to note is, this is hard to read, but this says discard. The idea is that what it's going to do is it's going to, I believe, load the latest block, run a transaction against it in terms of things like buying gas, and then Checkpointer has the ability to throw away results. So you can do a speculative run, and when it interacts with Pact service, it gives it a database where Pact can do whatever it wants. Because a buy gas actually is a write to a database. It's going to, write the withdrawal, and that operation succeeding is what allows the pre-insert check to verify without a doubt whether or not you can pay for gas. So a bunch of those things happen. Another thing it does, I think it actually does it before, is it does the Pact lookup. And so this is one of the first things it wants to do is make sure that it's not a duplicate. So it calls the Pact lookup API, which hits the process transactions. Again, this is versus what Pact service thinks is the latest block, or actually, correction, probably what Checkpointer thinks is the latest block. And so it rejects dupes. It rejects anything that can't buy gas. It does timing checks. It does a slew of checks on insert that ultimately have no effect except to identify bad transactions. So one of the things insert in mem, actually, this is wrong, sorry. Insert in mem it just rejects at this point. If it finds a bad transaction, it'll just reject it back. And I don't know if Heatkin or Francesco's on the call. One thing I don't know is if you send in a batch of transactions and one gets rejected, does it reject the whole thing?
It rejects the whole thing.
Okay,
so if any one of them have a validation failure, the whole request gets rejected and it doesn't even get to the mempool. Or
right. Okay. So yeah, the bad list doesn't get populated.
Can I quickly add something?
Yep.
But there's a rejection stage 0 that happens inside the send handler. where it trivially rejects anything that's structurally wrong, and then the mempool does some checks, and then Pact does some checks later. I believe that's it.
Pact doesn't do them later. It doesn't in this. It doesn't in these.
Yeah, pardon me. That's what I meant there.
That's all part of insert and mem does all these things, but the one thing it doesn't do is add its badness.
Yeah, the same thing inside the send handler. I believe it just it either filters out the bad ones or it rejects the whole thing. I can't quite remember.
Actually, I was talking about the ones that you rejected right away, like TTL or something like that. But
Right.
I'm not sure if like there are some cases where transactions get in.
Right. That's later. We're not talking about that right now. The important thing to note here, by the way, is that send. So for everybody who's not really familiar with this workload, send does not execute Pact transactions per se. Send, its main job is to fill in the pending transactions database, in-memory database in mempool. Once send is done, it means that you have transactions sitting in the pending pool. That's it. And the bad list is later. That's a mistake.
Miners do the execution. Is that correct?
Correct.
Well,
I mean, we'll get there.
one more question is, so when Pact pre-insert check fails to reject, if it succeeds, it's no guarantee. Can still
No guarantee.
It can still fail later on.
Right. Well, a classic example is we're doing this preemptive gas check. By the time you actually get into a block, you could have done another block or something, and you could have run out of gas. So there's, so this is just, most of the checks we're doing beyond the validity checks that Colin mentioned in send handler are, are speculative checks to try to, prevent people from doing bad things early on.
So how much of a DOS vector could that be? If I spam essentially with bad transactions that would fail in Pact pre-insert check, would be currently we are open there, or?
Yeah, we probably need some kind of throttle or something on pre-insert checks. Or at least they should be in a priority queue and probably get thrown out as soon as another one gets called or something. I don't know, that. I think if the pre-insert check is not, it doesn't end up being terribly expensive. I think the main thing is that if you had a bunch of them in there, it would slow up consensus, but they don't take that long. But it's hard to say because they don't run the transaction; they just run the pre-gas.
Okay, so it's cheap enough that we could handle with classic DOS protection measures like
We
throttling.
think, there might be something where we have to put, we have to back off or something. What this is, the DOS that this is really trying to prevent is what happens in the next slide. So let's move on to that because I think distinguishing between send and mining is going to be very important for people because when you send something into send, you think, oh, I'm making, this is a transaction, it's going to go into a block. No, send is just putting something into pending transactions. You need a miner to actually execute it. So let's look at new block. So new block starts over here. In my greps of the code, it's a function called with mining coordination that calls Pact new block. Now that may happen. I don't know what the relationship there is of that to consensus, but that's just the code I saw that is actually calling Pact new block. And what it expects to get back on success is a payload with outputs object. And actually, one question I did have is, I believe that then goes into payload. Payload with outputs that comes out of here, but is that not true? That would be for Lars and Colin. Or does that happen later?
No, but during mining, we put it already in the payload that I think when we. Oh, actually, no. Honestly, I don't know, but I'm pretty sure that everything that gets mined gets immediately validated after that, and that's certainly when we put it in. It might be that the mine already puts it in and it gets just orphaned in there. I'm not 100% sure. I don't think we put it in, but I'm not 100% sure.
I'm not sure about that, so I'd like to.
So one thing may be important is during mining. Therefore, I said it's not during mining it gets executed, but we don't trust miners. So even if it's mined, it's not yet on the chain.
Right. I think I'm gonna strike that out.
And I'm pretty sure we don't put it in the payload DB because we put the payload into the cut that we mine, give it to validation. I think only validation puts it in. Although it wouldn't be bad.
That's what I was assuming. Yeah.
Yeah. It wouldn't make a big difference, but it would be kind of potentially stalled data because we don't trust the miner.
Right. Okay. Anyways, so it's not going to go into the payload with outputs into the payload DB. So that part's wrong, but it does get back a payload with outputs. And as far as Pact service is concerned, from here on out, it's a black box. I mean, we're just talking about this new block flow. So again, Pact new block is an API call, so it's behind the Pact queue. So any other calls that are in here it'll come in after those, and then it calls this function exec new block. So one thing that's going to happen is in the information coming with the mining coordinator is the parent header, and so the first thing we have to do is get the relational check pointer into state. And this might involve a rewind. So if this is, if the most recent thing that Pact saw is an orphan, then that means we might have to go back a few blocks and play forward to get into the right state for a new block. Now what you'll see here is that all these calls to check pointer have discard associated with them. So what that means is that anything that happens in new block is all speculative and will be thrown away. So it won't move. I even think the rewind 2, this is something I have to check. I even think the rewind 2 might be speculative. That I have to check. I'm not sure what that is. So the point of exec new block is to run transactions speculatively and make sure that they all work and are all well formed and actually can go into Pact and come back out. Most importantly, the gas can be bought and things like that. So but the other thing it has to do is actually form a block. Mining coordination does not have a direct connection to mempool. It just calls Pact new block. So when we go into exec new block, we do what's called do pre-block, in which we have this thing called a validator function. That's important because it's basically a callback. It's something that complicates the relationship with Pact and mempool. So when it's going to call get block in mempool, it's not called that, but again, this is the business function that actually implements it. And all this does is interact with the pending transactions. So it's going to look at the list that was previously been populated by calls to send, as we saw before. And it's going to put together a block, but on all the transactions that it runs, it's going to run this validator function. And that's very similar to what happens in Pact pre-answer check. It's going to run a bunch of business rules. It's going to try to make sure that you can buy gas. So this is something that can seem a little wasteful, is that obviously when we run the transaction for real, we're going to buy gas. So we do end up doing it twice. We call this get block in memory with this validator function, which calls back into this validator function, which has to, do the whole check pointer. I mean, we have to set up the check pointer for that. We don't set it up for each one, but we have to. Check pointer has to be in state to be able to handle this, and it's a fair amount of work. And I believe we discard the results. Yes, we discarded the results after that. The check pointer is going to do a whole, play and rewind of it.
But we assume, so the rewind happens before. So the first check that we did on send was essentially against any state in PactDB. This thing is now against the real state.
It's against the parent header state.
Yeah, so it's the one that in the end the block will be based on. And the rewind, so the assumption is that rewind is expensive one. Is it correct?
Ish, I mean, probably. It doesn't do a lot. I mean, yeah, rewind's fairly expensive, but I believe it's a single rewind for this whole thing. So we're going to rewind once, but I'm pretty sure that's with discard too, like in the sense that I don't think we're going to permanently reset the check pointer. So the check pointer has the ability to nest transactions, so you can do an entire operation under various levels of rewind. So rewind, but I got to make sure about that, but I'm pretty sure rewind doesn't stick in exec new block. That's an open question. So the pre-block runs against the current state and does these half gas pies, which it then throws away. so that it can go back and, oh, that's one thing that is definitely missing from this diagram is, arrow. Is this also populates the bad list. So anything that gets rejected in this validation function populates a thing called the bad list. And the reason this will become clear when we get to poll and listen is that we need some way to tell the user endpoints that their transaction got rejected in a pre-block scenario, because it won't make it into the payload DB. So that's what the so-called bad list is for in mempool, is when we do this, get a block, run the validator function, and some get rejected, those rejected transactions will go into the bad list store. And as we'll see later, when we get to poll and listen, one of the things they're going to do is check the bad list store.
Quick question.
Yep.
Bad list is in memory, right? So if the node restarted, we would sort of lose that implicit information, right?
Correct.
Yes,
Okay.
all of mempool is in memory.
Yeah, that's what I
We
thought.
don't persist anything of the mempool. If it goes down, we just start over again.
But it's not if one node goes down, it's if all nodes go
Yeah.
down because it's distributed, correct?
That's the reason why we keep in memory, because usually if it's a floating thing, it stays in memory, but if a node goes down, it comes online, it just pulls what it gets from the other node. So usually it doesn't go. Yeah, it's not easy to delete something from the mempool.
And then two other things just bouncing off of what Doug just said was I believe that the bad list is not shared.
Nope.
And across nodes, and I believe that the bad list is also capped. It will clear out. It will only hold so many at one time.
Wait, the bad list is or is not shared? It sounded like Lars said it was.
It's not shared.
It's not shared, but we check first before we forward any we only forward transactions that went through validation. We don't forward, if I remember correctly, or
Right.
maybe
Anything going in the bad list is not going to get into the payload DB.
and it's also not shared with other. We don't share the bad list.
Yeah, does it? Oh, and does it get gossiped?
Yeah, that's what I'm asking.
Yeah, we don't share the bad list, but we also don't share transactions that are on the bad list.
Right. So one thing we're not discussing, by the way, in this whole thing is the fact that mempools gossip with each other. So that, insofar as we might need a discussion of mempool itself. This is not focused on mempool itself. This is focused on how mempool interacts with Pact service and Pact API.
Fair enough.
But mempool, it is worth noting that there's a lot more to mempool, because mempool has to gossip all these things to other Chainweb nodes.
And I think we may have another session scheduled for mempool.
Yeah. So let's move on from mempool.
Okay.
Main thing to note here: new block is going to request transactions from mempool, which it's going to retrieve from pending transactions. It provides a validator function in I/O, which allows these transactions to do the same kind of checks that were in pre-insert check. That's that VF with the discard arrow to relational check pointer, and bad transactions go into the bad list. And then once that's done, get block in memory returns transactions to be executed via the exec transactions function. Another thing to note here is that exec transactions does another, gets ready to do another transaction meta transaction that it'll throw away. And this is how the Chainweb Pact DB is set up for use with Pact. So the word Pact DB is basically an interface that Pact needs in order to interact with the database. This discard call, any of these calls, any setup for the relational check pointer is to make it that Pact and transaction exec have the correct version Pact DB, at the correct point in history to start working with. So exec transactions is basically going to run the whole thing. And what it does is it assembles all of the results of this into a data structure called payload with outputs, and it gives that back to mine coordinator. If there's some kind of fatal error, that would just bubble up the mining coordinator and get logged. But it's important to note that once you get to exec any of these things, like a failure in pre-block results in bad list being populated. A Pact failure, in other words, you have a well-formed transaction, but you did something that's illegal inside of the Pact interpreter, simply results in a failed transaction, and you get charged all of your gas. It's also important to note that while we did a pre-gas check here, part of running a transaction is to, again, charge the gas, and then at the completion of the transaction, fund the miner. So any Pact transaction has at least a full transfer where it takes money out of the sender account and then actually refunds. It takes the gas limit's worth of money, the full gas limit, before the transaction starts, so that you can ensure the person has the money. And then it refunds any unused gas to the sender, and it gives the balance to the miner account. And the miner account is supplied by the miner.
In these transactions, the Pact database, does it contain history, or is it really just a state, essentially incrementing? Let's say there's a refund to the miner, it increments the count of the miner, or does it remember the history of things that?
It doesn't. Pact maintains it does both. It maintains both a journal and a latest view.
Oh, so the journal really has all of the history, essentially. So in the Pact database. This explains why even if I only do transfers, my database grows.
Correct.
Okay.
And that's the kind of thing we can prune. We can prune history. It'll mean that some of those functions we've been talking about, like ticks log, there's a family of Pact functions that have to do with transaction history that we disallow from running inside of transactions. We try to call ticks log in Chainweb. If you try to call ticks log, it'll fail because we don't allow transaction history to be part of a transaction. That way, our Merkle trees are not subject to transaction history. They're only subject to the current state of the database.
Oh, that's good to know. But it also explains, I was wondering when I was just running transfers or just empty blocks, why the Pact database would grow at all, because I was thinking it's just, incrementing account numbers. But
that's yeah. Okay. And it's actually 3 database transactions because you could be refunding money you're often refunding money to the sender. So there's a debit of the whole gas limit before, there's a refund of the unused gas, and then there's a credit to the miner. I also didn't point out in here, there is a Coinbase transaction that occurs. That's probably worth noting. That should go in here somewhere. So there's Coinbase. That's a one-sided transaction in which the miner gets credited. That doesn't show up in the transaction list. That goes into the payload with outputs as a dedicated Pact transaction. So again, all this stuff gets run through the transactions. All the transactions get run. The results of these are put together into a payload with outputs data structure, and the whole thing is discarded. The entire block, the only result of it is the payload with outputs given back to the mining coordinator so that the miner can get the hash to start mining against. So that's the end of this block. Let's move on to validate, which is the kind of, as Lars says, the validate happens in 2 cases. One is the miner finishes mining the block and has a good hash, hands it to validate. The other scenario is a header and payload with outputs comes in via consensus sync. But as far as Pact is concerned, these are the same things. So this is why Pact throws away results in new block. Pact is not going to save a permanent record of Pact transactions until it comes in via validate.
And by the way, consensus also doesn't distinguish if it was mined locally or comes over the network. Anything that is new goes through validate, and we don't.
That's why I crossed this out here.
Yep.
That it doesn't go into the payload. This is how something ends up in the payload DB. And so the first thing that happens is in web block header DB in the sub function. We should move this to a top level function so people can find it. By the way, Lars, validate and insert payload.
Yeah, I have a change in the pipeline which kind of got pushed back to the 20 chain, but in the other branch I'm working on, the async, this thing will move much higher up and will be much more visible.
Right. So anyways, validate and insert payload, just grep for that if you ever want to see where this happens. It happens inside this big sync. It's a function called insert, which is a little confusing, but it does tell you what's happening, which is that if the block header gets inserted, part of that insertion is to find the payload and run it, validate it and insert it. It's a well-named function because validation is giving it off to Pact to rerun this block or run this block for the first time if it's coming from outside. And we've already described a lot of what happens because of what goes on in new blocks. So the big difference with validate block is that when it interacts with a relational check pointer, it plans to save it. So everything it does in terms of like rewinding. So at this point, if we're on an orphan and we need to go back 3 blocks, that's going to be permanent now. The check pointer after this validation is going to be on this new fork. Any old forks are orphans. So the check pointer only has one view of history at any point in time. In general, for normal operation, this is actually very, very efficient. It just means that when you have forks, you do a little bit of extra work. And if you have deep forks, we have actually put in a limit on how much you can rewind because we've just decided that Pact can't do it. If you want to go back 20,000 blocks, it's just going to take forever. So that was part of our nightmare in early, when we had big forks when we were launching Chainweb, is that in addition to whatever other problems it would cause, Pact just couldn't catch up.
And you can do it, but you have to do it manually, essentially. You have consent to it. You have to put it in a configuration, say, yes, please go back, jump to this other fork, but you don't do it automatically.
So it's going to rewind. That gets it to the header, the parent header that is the correct state to run these transactions. Now, remember, one thing is that we already have a payload with outputs from a previous run, whether that's from the miner or coming in over the wire. So not only are we running this block, but we have the results of a previous run. But as soon as exec validate block, it's going to ignore that momentarily and just be like, okay, this is the new block to run. The big difference being the relation or check pointer is going to save it, but it does the same thing to set up the Chainweb Pact DB for transaction exec. I think it probably does the dupe. I think it probably checks against the transaction, the dupe transaction. Probably part of its validations, I need to see this, as if this is true, is whether or not it checks for dupes.
And then one other.
I certainly hope it does.
And then just to kind of make a connection for people who may have heard things, what you just said about the check pointer only keeping one state of the world, what Greg was working on with what he called the tree-like check pointer was basically intended to allow it to keep track of multiple. Is that correct?
That's right.
Okay. And it's not decided whether that's something that we need or not, but it could conceivably be.
It's not so much about the tree. It would give us a tree, but most of the time we don't jump to other branches, but we go back and forth in history. That happens actually quite regularly. So it's more like going 2 steps back, going 2 steps to the front. It's pretty rare that and they'll often happen. Orphans are usually off steps one. So it can be kind of going 1 step in the wrong direction, going 1 step. It's not like a big tree, but it says just going back and forth. We wouldn't commit immediately, but we could go, essentially, we don't have to do IO for the short kind of going back and forth.
What I've done a spike of and what Linda is studying right now is a tree supporting small in-memory check pointer that at some point enforces a linear history some number of blocks back. So it keeps blocks in memory until some metric is passed, at which point it says, okay, this is the real history that we save to disk. And so that kind of makes the palm tree kind of thing. It leverages what Lars was just saying, which is that most rewinds are just 1 or 2 or 3 blocks. By keeping all of those in memory, And then only, so when a rewind happens, it more often than not will already have the block there, just sitting in memory. Now, one of the reasons why this doesn't end up being very expensive in practice is that SQLite is a pretty smart system, and it keeps a lot of this stuff in memory as it is. So that's why we don't suffer tremendously in this stuff.
And by the way, that's also the reason why we are very careful to never have things that have to look in arbitrary points in the history, because all the databases that we use are very good on locality. So if you kind of always look in the same region, kind of things that are close together, they work very well. If you store things all everywhere around, they get bad. For example, even the payloads, even the content address, we prefix them with the block height just to make sure they are on the same place on the disk.
So exec transactions is, it is also missing an arrow, obviously. Oh, wow. That's preview. Exec transactions obviously also calls transact and exec and pact, and that's been set up with the pact DB that's in the right state. And again, the big difference here is that when this is all done, it's going to all be saved. So all these transactions are now going to become part of the permanent pact history. And one of the reasons for people who are asking about history, one of the reasons why history is supported without too much effort is that the same history, every pact transaction update is stored with its TIX IDs such that it's easy. In other words, the table has all the rows. Actually, here's the best way to put it. Pact is a key value database. So for a given table, you have a key and a value, but what relational does is it adds the TIX ID to that composite key so that when it comes time to rewind, it just deletes everything later than a TIX ID. It's got a separate table in there that relates TIX ID, that has the latest TIX ID for a given block. So when we go back 3 blocks, it queries that table and says, hey, what was the last TIX ID? And then it just blindly deletes everything after that for the tables that are storing data. And that's why we don't need a separate transaction log. In fact, behind the scenes, Chainweb PactDB is only a journal database, but it makes a fiction to Pact that it has a latest value, because every time it does a select, it's actually selecting the highest TIX ID. So exec transactions, much like we saw in exec new block, runs through all of them. Again, important to note that some transactions can fail as a Pact failure, and then that's not a problem. Those become part of the results. And then the big thing it does is this function that you've probably heard of called validate hashes. This is, if we ever see the dreaded hash mismatch, it's coming out of this function. And what this function is doing, recall that the call to this function took a payload with outputs from a previous play. As we saw before, exec transactions creates a payload with outputs when it comes back. So we've now got 2. What we're going to do is we're going to make sure that those, we're going to check the master payload hash, the top level payload hash, and if they're off, validate hashes then does a deep kind of forensic dive and tries to give us information about what went wrong. It's usually some output. And what it tries to do then is go through each of the transactions and see if it's rarely input. We almost never have inputs are hashed by the user, so we almost never get, we don't expect to get any hash mismatches on input. That's not to say it couldn't happen. Someone could send us a bad block, that is missing transactions, or a bad payload with outputs that's missing transactions. So you have to validate absolutely everything, but more often than not, it's either the Coinbase output or the transaction output that have different hash. And basically we get a bunch of forensic information in a monstrous error. We throw an error that's got all this forensic information, and that goes into Kadena. And then we all scurry around and try to figure out what happened. Normally that succeeds, and that gives us a great deal of validation, because we know that all these hashes have merkled up into the same result. And that's pretty much it. At that point, web block header DB is satisfied with this payload with outputs, and it'll put it into the payload DB. So the payload DB is the final resting home of a valid block and of transactions. Another thing is obviously that I forgot to note is that successfully executed transactions do want to go into this process transactions database so that later we can say we're avoiding dupes. We don't want to execute a transaction twice, basically ever. We don't have a practical limit on how far back we prevent dupes. So that's something maybe one of these years we'll have to figure out is how far. But since it's just hashes, it's really not that much data. So, and it's on disk. So,
and we currently just go over the full database because it's small enough. But that's the reason why we have this transaction creation time and the TTL. We validate that, so they go into the payload hash. That means we can search for, when we search for duplicates, it's enough to search only the window where the transaction could possibly have been valid. And this means for the current block, it means we only have to look into all transactions, or into the window where all transactions that could make in the current block.
So we can print this with max. We could print it with max TTL. Okay, so that's validate block, and that kind of concludes the the main logic of how well, no, let's go ahead and go to poll, because that's what the user is gonna. Our user comes back in here. Poll takes what I wrote, RID or request ID. That's basically the hash of the transaction. Listen is a stateful call that both calls send, as we discussed before. And since, as we noted, send doesn't, it does some instant validation, but otherwise it just waits around. What listen does is it does both. It basically blocks on and pulls and calls poll in the background. So it's a convenience function to send in something and not have to do not have to do the polling yourself. Poll is supposed to come back very quickly, and that way you're supposed to be able to tell, you can do your polling yourself. But
listen calls send.
Yep.
Oh, I was thinking that listen was just repeatedly.
Oh wait. Wait.
Listen is called send.
Am I wrong about that, Tikian? I thought listen was like send and.
I think it's just a list of request keys.
Listen. So I don't know what goes on behind the hood, but I just consider listen as like poll, like constant polling until.
Oh, okay. I'm sorry, so that's my mistake. I think that's wrong.
I think it's blocking. It's
just polling for you.
Yeah, the Pact read the docs says that listen takes a request key.
Okay. So let me just correct that.
And one more question for Paul. Is it? I hope it's not just looking at the payload DB. It's also checking that it actually made it onto the chain, because the payload DB can have orphans. So the payload DB, kind of the source of truth, what is on the chain is, in the end, it's the block header DB or the Pact DB, depending on where you want what you consider source of truth. But so just because something is a payload DB doesn't mean it got accepted on the chain.
I think. Well, actually, I think we have evidence of poll coming back sometimes and then not coming back, or coming back with a different block header. And we also have examples of polls failing.
I would hope so, because one thing we know is that one thing that I think is not in the pictures here is that the payload DB has kind of lives along with the block header DB, and the block header DB is really what also Pact execution and validation looks into. Before it goes to the payload, it first goes to the block header.
Right. So hold on. So let's talk about what poll does. So I was wrong about listen. Listen doesn't take a text. It just takes a single request ID, whereas poll can take a list of request IDs. And so the first thing it does is it actually checks the bad list in mempool. Because as we discussed before, when when new block gets created, one of the things it does is populate the bad list for failures. So this is how you can, we didn't used to have this, and this was a very bad user experience. So this is poll and listen can now find if something got executed in pre or insert and fail. So that's the bad list check. The other thing it does is it goes to the Pact lookup, on the queue. It puts something on the queue to hit the process transactions. Remember, one of the things this is going to do is tell it what header to look it up in. So the data it gets back from this allows it. So these aren't really in order. The payload DB is, I believe, the last thing to go. So based on whatever the latest checkpointer state is, it's going to hit payload DB. So that, of course, that could mean an orphan component. But it's going to be based on whatever the latest state of the relational checkpoint. That's worth.
Yeah, that makes sense. Because whatever is in the checkpointer, I remember we checked that it's in the block header DB. Because the checkpointer is only updated when we do a validate, I think, isn't it? Yeah.
So this is really like 1, 2. So that's what poll is doing, checking the mempool for bad list, getting, obviously if it doesn't find a process TX, that's where you're not going to get a result because it's still hanging out in pending. One question one of the things about poll that's a little frustrating is the fact that you don't get any information whatsoever. It wouldn't necessarily be the worst thing if poll had a pending result because that would actually, to a certain extent, that would be at least a little more information on the transaction. Right now, you just get an empty list. You get an empty object. You get nothing. Fuck this.
One question, Stuart. In the new block section that you had 2 arrows going from get block and mem. Yeah, and that one to pending TX. So based on what you just said about poll, when a transaction goes from pending to get block and mem but fails validation, does it get reinserted into pending TX?
No, that's an eviction.
That's an eviction.
Yeah.
But if you did poll, you would still get like the empty thing, so the user wouldn't know that it was evicted, right?
Realize at that point. What's that?
So then if the transaction was evicted and the user does a poll, it wouldn't know if the transaction is pending or if it was evicted, correct?
Well, but that's what I'm saying. Like, if we
Right.
already have one that says evicted, it might be nice to have another one that says pending.
Yeah.
We know if it's pending. I mean, like,
Mm-hmm.
there could have been like maybe you missed your, who knows? It's not the worst to have it be empty. It's just it's just something I've noticed that's like,
I was wondering if generally, even for the mempool, we instead of having bad transaction and transaction just returning a flag that also tells you why it was evicted, just having a transaction state that we keep around. So instead of just telling mempool, this transaction.
Now. We finally have error messages coming out of there.
Yep,
it used to just be like,
yep.
There you go. But now it actually at least tells you why it's in the bad list.
Yeah, but having a transaction state might be something that could make sense. Just always attach the state, like pending, rejected because of something or so.
Well, I mean, to a certain extent, we do that by what database it lives in, right? I mean, payload DB means it's good. Pending means it's pending, and bad list means it got rejected. So, we have that state. It's just it's implemented implicitly by where it's stored.
Yeah, and not given to the user necessarily. So we could just add it.
No, I know. Yeah, right now we don't rationalize that into like a nice thing. And what's more, I think poll might be. Well, poll. I don't know if poll has the same. Kevin was talking about this before. I don't know if poll has the same problem where if you do a batch. We got to get to the bottom of this like send versus poll thing and what those semantics should be. And it's really probably what Kuro does.
So pool, when you have some transactions that went through and some transactions that's still pending or that doesn't exist, then it only returns the ones that are in the DB. So
Right.
even if you send in like 7, you can get back 5 results.
Right.
But how do you know to which transaction then the 5 return? Oh, it's an associative array. What comes back?
Yeah.
The pool gets a object, and the keys are the request keys that you.
I think it's just a list, right? It's a list of
No, pool is an object.
It's a map. It's a hash map.
Yeah.
The result is, but the submission I think is a list, right?
Oh, the submission is just a list. Yeah.
Yeah, it's a list of request IDs, and then what you get back is a map that's associated to those.
Oh.
It gets turned into an A list of results, if any. It doesn't include keys that don't have a result. See, that's one of the reasons why a pending result could be nice, is just because then. But you know, when Pact was designed, the API was designed for a private where you almost never have this pending. So it's so fast that it didn't seem useful.
Yeah, but there could be other states too, like telling the user if it's reintroduced, for example, or things like this, or often. So
you'll find that out. I don't think actually when something gets orphaned, I'm not sure. Do we? Oh yeah, we have some way to do we have a way to reintroduce? I guess we do.
we reintroduce. So, but the user won't be able to tell them if you just had an enumeration that we attached to a transaction mempool that just keeps track of the things. We could just have transaction states that are an enumeration type or something like this.
From this diagram.
Just a reminder, we got 10 minutes left.
Yep. Well, we got through the meat of it. Okay.
So is that a question that you guys are trying to investigate? Whether
I don't know exactly how it's done. I need to go look at how that. So the idea is that here, something in line 2 is going to tell us if something got orphaned. And I don't know where that. I assume it happens in here. If anybody knows. Right? I'll look into that and try to update. But that is an important thing. Obviously, if something gets orphaned, all those transactions need to go back into pending TXs.
Well, we have a configuration setting for it, so you can turn it on or off, but it's on by default.
It's definitely on. It's a terrible. We should never turn it off. That's something a blockchain has to do. Orphans have to reintroduce transactions.
And I think it happens. The checkpoint on rewind to do it, but
I just didn't think about that. That's actually another endpoint in the mempool. There's a couple other endpoints in the mempool. These things. So I'm missing some.
Isn't it just using insert mem? I think it just uses the same. It just
I don't know. I'll have to look at it. All right, so let's get to the last use cases, which are pretty simple. I actually think we're on the last use case. So the last use case is local calls. And this takes a single transaction from the user. It completely bypasses mempool because it doesn't have, and it completely bypasses payload DB. It doesn't involve consensus. The only thing it does is it basically asks the relational check pointer for what its latest block is. So whatever the check pointer thinks is the state of the world is what, and that's based on the last thing that went through validate. So wherever validate left the check pointer after that save, all that validate block saves its changes and updates all these things. That's what local is going to run against. And you do get that information back now in local, what block it ran against. It's obviously going to do with discard. Local is 100% safe. You can send anything you want into local. You can define modules. You can do anything you want, and it gets completely thrown away. And then it basically just, as usual, relation check pointer is used. It doesn't. I don't think it does a duplicate check. You can send the same hash over and over and over again into Pact local. Doesn't matter. And then which is interesting because you can send in a transaction that already succeeded and you can send it again into local. You don't have to change the hash. That's kind of useful if you want to do a quick, like that's how I would test that when we were having these problems with modules that I couldn't dupe install a module. I didn't have to reset the function. Oh, actually, yeah. I don't have to reset by doing it in local, I can just get into the innards of Pact and see Pact reject the duplicate or reject the upgrade of the module because of governance. So Pact is fairly forgiving. Emily worked on some stuff to make Pact unforgiving with respect to our business rules because sometimes you want to know in local if your gas payer is right, if all those other checks that, but on the other hand, it's a really nice thing the local doesn't do those checks so that you don't have to get all that stuff right and you can just fire in a transaction or a query and not have to, you have to populate those fields, but they don't have to be correct. Like the TTL, time, all that stuff doesn't have to be there. So that's a tension that we have right now in local is how to do a dummy, something where we want it to give us all the errors that might happen in send, specifically in usage. So right now it's fairly forgiving. It sets up the check pointer, which sets up the DB with the latest, gives the latest version of the DB to transaction exec. It basically just directly returns, runs in transaction exec, and gives back the result immediately to the user. By the way, the way this queue works, since it's another thing that goes in the Pact queue, the way all the Pact queues work, functions work, is you put something on the queue, but it always is paired with an mvar. That is the result. So there's always an empty mvar on the queue item, so that when an exec new block, an exec validate block, in any of these, there's an mvar waiting to be populated so that the person who put something on the queue can block on that mvar coming back. And it's a one-off mvar, so there's no race conditions or anything like that. So local handler just goes to Pact local. This all happens. When it's done, it populates the mvar with the command result, sends it right back to local, right out the door to the user.